Welcome back. In this video, we'll be talking about the disinfection part of water treatment, and we'll be talking mainly in terms of the forms of chlorination. There are different forms of chlorination, here. One is plain chlorination, pre-chlorination, post-chlorination, and double chlorination. Plain chlorination means application of chlorine to raw water as it enters into distribution system. That means without any treatment. So only chlorine is given, no other treatment is given, directly go to users. Pre-chlorination. Applied chlorine is before treatment of water, particularly before filtration or sedimentation tank. So this is the chlorine applied before treatment going to the users. Post-chlorination means applied chlorine after the treatment is completed. So at the end of treatment, you are going to apply. In the pre-chlorination, the dosage should be adjusted to have 0.1 to 0.5 milligram per liter residual chlorine for pre-chlorination, but for post-chlorination, residual chlorine should be around 0.1 to 0.2 milligram per liter after the minimum 10 to 20 minutes of contact time. Double chlorination, sometimes we are going to add chlorine before treatment and after the treatment as well, depending on the microorganism load expected, particularly during pandemic situations. Superchlorination. Applied chlorine beyond the breaking point. The dose should be such that it should have at least 1 to 3 milligram per liter with a contact time 30 to 60 minutes. With higher dose. Adopted in case of epidemics, droughts, high concentration of impurities noticed in water. Particularly, this is where we are going to make use of. Dechlorination. Removal of excess chlorine applied during superchlorination. You're already applying extra chlorination, it should be removed. This is achieved using the sodium thiosulfate, sodium sulfate, activated carbon, sodium biosulfate, potassium permanganate, sulfur dioxide, etc. Then we are having one breakpoint chlorination. This is an experimental determination of optimum dosage of chlorine. When pre-chlorination applied, what is the advantage you are going to get? It reduces the amount of coagulant requirement, reduces the bacterial load on the filters, and helps in maintaining longer filter runs. It eliminates the taste and odors, controls the algae and the planktons in the sedimentation basin and filters. The breakpoint chlorination, if you look at, this is applied, this is generally determined for experimentally for identifying the optimum dosage of chlorine. When chlorine is applied, a number of reactions are going to take place. Inorganics will be there in the water, organic impurities are there in water, and ammonia related compounds are also there in water. Chlorine reacts with all these things to convert into corresponding compounds. So it applied to, when chlorine is applied to the water, two actions take place. Killing of bacteria, oxidizing the organic matter. When chlorine is added to the water, it kills the bacteria first in stage 1 with a low residual chlorine. So this is stage 1. Inorganic chemicals such as iron, sulfide, nitrate, etc. will also be oxidized. So this is stage 1 part. In stage 2, here chlorine reacts with ammonia to form chloroamines, monochloroamine, dichloroamine, trichloramine, during which residual chlorine increases. So this is, you see, residual chlorine is on the y-axis and the amount of chlorine added on the x-axis. You can see here, and residual chlorine slowly increases and reaches to a point. Now this is the stage where organic compounds or impurities are there, but they will be oxidized to corresponding chlorides. That shows the decrease of residual chlorine. So this is the stage 3. The chlorine amines are reduced to nitrogen at this stage, finally. And afterwards, there's no other requirement. Whatever the chlorine you are adding, it is remaining in the water, and complete residual chlorine is obtained here. From this point, you see there is no change in the residual chlorine pattern and is uniform, say with a 45 degrees angle. So this is called as a break point. Beyond this point, the chlorine is available as a free available chlorine and a constant residual chlorine is maintained. What are the advantages of the breakpoint chlorination? So it reduces unnecessary addition of chlorine. It removes the taste and odor, adequate chlorine residual, complete the oxidation of ammonia and other compounds. It removes color due to organic matter, and it removes manganese. And how it is obtained? In the experimental work, chlorine is added in different amounts of water to the sample and tested for residual chlorine. Orthotoluene test is used to determine the residual chlorine in the laboratory. And you can see here the graph is drawn between chlorine dose on the x-axis and residual chlorine on the y-axis. And you are going to get a trend, what we discussed just now. And we obtain here the lowest point, which is nothing but the breakpoint chlorination, beyond which residual chlorine becomes a uniform. From this data, you can see here the breakpoint chlorination dosage is 1 milligram per liter. And chlorine demand at this stage is 1 here. And what is the residual chlorine? 0.2. So 1 minus 0.2 is approximately is a 0.18 rather, 0.82 milligrams per liter. For a dosage of 1.2 milligram per liter, if you see for checking this value, and corresponding residual chlorine is around 0.38, and even there also the chlorine demand you see 0.82. So two values you have taken randomly, and then what you are observing is you're having a constant chlorine demand. That's what the meaning is. The breakpoint chlorination, it will help you to fix the optimum dosage and completing all the impurities reduction in the water. Let us look at two small problems. Calculate the amount of bleaching powder required per day to treat 5 mld of raw water per day if 5 milligram per liter of chlorine is applied in the plant. Assume bleaching powder contains 30% chlorine. Bleaching powder is normally used, one form of the chlorine. You are going to use approximately 30 to 33% of chlorine. So sometimes pure chlorine is applied or bleaching powder is also applied. So what is the water added here to be treated? 5 ml, 5 into 10 to the power of 6 liters per day. And how much amount of chlorine is used? 5 milligram per liter. Chlorine consumed is equal to this water treated multiplied by chlorine used, 5 10 to the power of 6 liter per day into 5 milligram per liter. It will give you 25 10 to the power of 6 milligrams per day. But 1 kilogram is equal to 10 to the power of 6 milligrams. So accordingly, the amount of chlorine used here in the plant, 25 kilograms per day. Now we are applying a bleaching powder instead of chlorine, having 30% of chlorine. So using that information, 30 parts of chlorine is there if we are using 100 parts of bleaching powder. 25 kg per day of chlorine requires how much of bleaching powder? So you obtain an equation and then find out that 83.33 kilogram per day. So that means if you obtain 83.33 kilogram per day of bleaching powder, you apply here in the plant, that is equal to 5 milligram per liter of chlorine required in the plant. In a water treatment plant handling 10 mld of raw water, 10 kilogram per day of chlorine is used. The residual chlorine after 10 minutes of contact time is 0.2 milligram per liter. Calculate chlorine dosage and chlorine demand in kilogram per day. And this is more important. Normally, we used to calculate these dosages in kg per day only instead of milligram per liter. It gives the total mass of the chlorine requirements. so that the purchasing of the required chlorine or bleaching powder, it will be more helpful for us. Bleaching powder will be available only in terms of so many kilograms package and all. That's why we try to calculate everything in terms of kilograms per day. Amount of water treated 10 ml, 10 into 10 to the power of 6 liters per day. Amount of chlorine used is 10 kilograms. It is nothing but 10 into 10 to the power of 6 milligrams. Dosage of chlorine we express in terms of milligram per liter. So you write down this milligram divided by this liters. And ultimately, what you are going to get, this is equal to 1 milligram per liter. Residual chlorine is 0.2 milligram per liter. So chlorine demand is chlorine dosage minus residual chlorine. So 1 milligram per liter is the applied dosage and 0.2 is the residual. So demand is 0.8 and this should be multiplied with amount of water treated 10 mld and ultimately you're going to get chlorine demand as 8 kilograms per day.